We all feel fear. The ability to fear is a part of a human nature, and there just happens to be some situations when we just feel afraid. But why is that? Well, to find that out, firstly we need to understand what fear actually is. So let's look how it is interpreted by scientists. They say that fear is a chain reaction in the brain that starts with a stressful stimulus and ends with the release of chemicals that cause a racing heart, fast breathing, and energized muscles. It is why we feel a bit stronger than just a second before when we weren't afraid. The stimulus may be a spider, a knife at your throat, an auditorium full of people that waits you to speak, or the sudden thud of your front door into the door frame. Because cells in the brains are transferring information and triggering responses every moment, there are amounts of areas of the brain at least somehow involved in fear. But research has discovered that some parts of the brain play main roles in the process. Now you will hear some fancy words, but it is just how those parts of brains are called by scientists. At first we have thalamus, which makes a decision where the incoming sensory data should be sent from eyes, ears, mouth, or skin. Then we have sensory cortex, which analyzes received data. Then we have hippocampus, which collects, saves, and retrieves conscious memories, processes stimuli set to develop context. Then we have amygdala, which decodes emotions, determines possible threat, stores fear memories. And in the last place, we have hypothalamus, which activates fight or flight response. The process of creating fear begins with some kind of a scary stimulus and ends with a fight or flight response. The process of creating fear takes place in the brain, and we just cannot control it. There are two paths that are possible in the fear response. The low road is fast and messy, while the high road is longer and can deliver a more precise interpretation of situation. Both processes are happening at the same time. Let's take a look at both of these ways practically. The idea behind the low road is take no chances. If the front door to your home is suddenly knocking into the frame, it may be the wind. It also may be a burglar trying to get in. It's far less dangerous to assume it's a burglar and have it find out to be the wind than to assume it's the wind and have it find out to be a burglar. The low road shoots first and asks questions later. This is how the process looks like. The door knocking into the door frame, that is stimulus. As soon as you hear the sound and see the motion, the sensory data is being sent to the thalamus by brain. At this point, the thalamus is not sure if the signals it is receiving are signs of danger or not, but since they may be, it passes the information along to the amygdala. That is where it skips two parts of the brain that are not skipped in the high road. And what does the amygdala do? After receiving the neural impulses, it takes actions to protect you. It commands the hypothalamus to start creating the fight or flight response that may be necessary to save your life if what you're seeing and hearing turns out to be an intruder. The high road is much, let's say, smarter. While the low road is initiating the fear response just in case, the high road is trying to figure out all of the options that may be possible. Is it an intruder or is it the wind? That is how high road looks like. When your eyes and ears sense the sound and motion of the door, they send this information to the thalamus. The thalamus forwards this information to the sensory cortex, where it is analyzed for meaning. The sensory cortex determines that there is more than one possible interpretation of the data and passes it along to the hippocampus to establish context. The hippocampus asks questions like, have we seen this stimulus somewhere before? If yes, what was the meaning that time? What else is going on that might give me clues as to whether this is an intruder or a windstorm? The hippocampus may pick up on other data being relayed through the high road, like the tapping of branches against a window, a muffled howling sound outside, and the clatter of patio furniture flying about. Analyzing this other information, the hippocampus determines that the door action is very likely to be the result of wind. It forwards a message to the amygdala that everything is alright, and the amygdala in turn commands the hypothalamus to shut off the fight or flight response. The sensory data regarding the door, the stimulus, is traveling through both paths at the same time. But the high road takes more time than the low road. That is the reason why you have a very stressful moment or two before you calm down. It does not matter of which paths we are talking about, all roads are headed to the hypothalamus. This portion of the brain is responsible for the ancient survival reaction called the fight or flight response. As I have said before, there are a lot of different possible stimulus. For example, a spider, lightning, thunder, or even this was the example how practically your brain works when it receives some kind of stimulus. At least for a moment you were scared, that's the low road, but then you realized that there is no danger, that's high road, and then you calmed down. Now you may say, I understand how fear works, but why do we sense fear? Is it really so necessary for us? To say it shortly, we need fear to survive. Without fear, we'd be walking into oncoming traffic, stepping off of rooftops, and carelessly handling poisonous snakes. In humans and in all animals, the purpose of fear is to promote survival. In the course of human evolution, the people who fear the right things survived to pass on their genes. In passing on their genes, the trait of fear and the response to it were selected as beneficial to the race. Most of us are no longer fighting for our lives in the wild. But fear instinct is not gone from our lives. It serves the same purpose today as it did when we might run into a lion while carrying water back from the river. Only now we are carrying a wallet and walking down the streets. The decision not to take that shortcut through the deserted alley at midnight is based on a rational fear that promotes survival. Only the stimuli have changed. We are in as much danger today as we were hundreds of years ago, and our fear serves to protect us now as it did then. Also, there are such things as phobias, which are irrational and overreactive fears of something that most often cannot cause harm. There is no hard and fast reason why a phobia will develop. Both genes and the environment can be involved. So to conclude, the reason why we sense fear is simple. Firstly, we sense it for our survival, and it is entirely unconscious. And secondly, as in phobia's case, we sense it because it is in our genes or the environment formed this kind of fear. So as Veronica Roth once said, fear doesn't shut you down, it wakes you up. So that is it for now. Thanks for watching. I hope you enjoyed.